Okay, cool. So my name's Will Griffiths, and I work at Lunar Logic here in Krakow. So how many of you estimate projects at work? And how many of you enjoy it? Yeah, a few little. So I don't enjoy it either. So I'm here today to show you how to take a bit of the pain out of estimation and to remove some of the human bias. So what human bias am I talking about? Well, mainly the overconfidence bias. So as humans, we tend to fall into the planning fallacy trap. So Daniel Kahneman was famous for this. He's a Nobel Prize-winning economist. And he said that when humans plan for the future, they tend to estimate the best case scenario and they forget about all the delays and distractions and setbacks. So, and it doesn't get better if you're an expert, because experts suffer the same bias. So you have your plan, and then you have reality, which is very different. So, I mean, humans, we suck at estimation, but still we interrupt each other. We say, stop work, can you estimate this? And we get something that's overconfident and not very useful. So what else can we do? So at Lunar Logic, we started messing around with using data to do our estimation for us. And it's based on the brilliant work of Douglas Hubbard, Troy McGinnis, and Larry McEnroe. And methods like this are used extensively in risk management, physics, and finance for forecasting. So let's get to the estimation. Let me introduce you to Jarek. So Jarek is a developer, and he's been asked to estimate a backlog of 10 tasks for his client. So firstly, we need some data from Jarek. So we go to his task tracking app, Pivotal Tracker, Trello, whatever it is, and we download the data. And so if we put it on a calendar, it looks something like this. We have tasks that range from between 1 and 3 days. Sometimes he's working on no tasks, and sometimes he's working on 2 tasks. So this is all the data we need to start doing a statistical forecast. And our model is built on 2 parts. The first is lead time. So lead time, if you don't know, is the time from beginning a task to the time when it's finished. So when you drag it to the doing column to when you drag it to the done column. So why do we use lead time? Well, lead time is very simple to capture. It's in most task tracking apps, and it also takes into account a lot of implicit information. So it takes into account the time that Jarek had to stop work to fix a bug for 2 days. It takes into account sick days, unexpected planning meetings, all these kinds of things. And these are the things that we forget about when you're asked to estimate. But the data doesn't lie, so that's why it's useful. And we just make the assumption that these things have happened in the past, and so they're going to happen at a similar rate in the future. So here is his calendar again, but this time with lead times. I'm just going to arrange the tasks so it's easier to count. And so what we've got is we've got 6 tasks that took 1 day, 3 tasks that took 2 days, and 1 task that took 3 days. And we count up the probability, so there were 6 tasks out of 10 that were 1 day, so there's a 60% chance that it took 1 day, 30% that it took 2 days, and 10% that it took 3 days. So we use these historical lead times to predict the lead times for the future. Okay, so for the 10 tasks in the backlog, we start and we've got task 1, and we get a lead time of 1, lead time of 1, and a lead time of 2, and we do that for the rest of the tasks. And we add them all up, and we get a total lead time of 16 days. And so with 16 days, yeah, so we've got a total lead time of 16 days. But if you remember, sometimes he was not working, and sometimes he was working on 2 tasks. So we also have to simulate work in progress, and this is the second input in our model. So work in progress is the number of tasks he's working on at the same time. So for Jarek, it could be 0, 1, or 2. So we count it up in the same way as we did with lead times, and we get another probabilistic distribution. Now we have this, we use it to simulate how many actual work days it takes to complete the total lead time of 16 work days. So each square represents a workday, and we're going to predict a work in progress number. So it's the lead time, the predicted work in progress is 1. So lead time goes up by 1, work days by 1. Then Jarek takes a day off, and lead time doesn't increase because he's not working in this simulation. So then we simulate another day, and he's also not working. And work days goes up. And then lastly, we have a simulation of a work in progress of 2 tasks, 2 days. So he's working on 2 things at the same time. Okay? And we do this until we get a number of work days, and in this case, it is 18 days. But the thing is, this is only one possible future. Because of all the randomness, we can't rely on this one day. So what we do is we run the simulation again 10,000 times. Why 10,000 times? Why so many? Well, it has the effect of smoothing out all the randomness into a nice probabilistic curve. So what we do is if we count all the outcomes of all these simulations, we come up with a histogram that shows the number of work days to complete and the frequency, the count of how often that occurred. So we can see that the most optimistic is 9 days and the most pessimistic is 36 days. But it's probably going to be somewhere in between. So what we actually do is we look at the 50th percentile. So half the time Jarek is going to be faster than this, and half the time he's going to be slower. And so it's 20 days. So we can take this 20 days as a risky delivery date for the backlog of 10 tasks. But what if that's too risky? Well, we can take the 90th percentile as well. So 9 times out of 10, Jarek is going to be faster than this day, which is 26 days. So we have here a range of 20 to 26, which allows Jarek to go back to his client and have a much different discussion based on statistics and data, and say, look, I might deliver between 20 and 26, and these are the probabilities. So what are some of the other benefits of statistical forecasting? Well, if his client comes back and asks for an estimate for 15 tasks, well, he's got the data, he can just click a button, and he's got a new estimate. Secondly, as I mentioned, there's less human bias, so it's better information for decision making and planning. And lastly is you can take the data of old projects and apply it to new projects. Of course, you have to be careful with the assumptions you're making, and ideally it's a similar team with similar type of project and similar complexity of tasks. But yes, we can do that. So this is not a silver bullet. You can't just go and put in some shitty data and expect a good number. What you put in is what you get out. So you have to be careful with that. So that's one thing to watch out for. And if you don't have any data, well, you can't make an estimate until you've collected that data. So at Lunar Logic, we built a tool that helps you do it, and we've made it free for available at getprojector.com. We think estimation should be less painful, and we'd like it to be the norm in software engineering. So if you'd like to go and take it for a spin, we welcome that. If you have any problems with the assumptions, or you'd like us to check your data, then you can email me at will@lunarlogic.io. And if you're not ready to get your feet wet just yet, you'd like to learn a bit more, our CEO has an awesome blog post on our website, How We Estimate at Lunar Logic. So the last thing I just want to leave you with, one final thought, is we're making a lot of assumptions here. Our simulation doesn't have to be perfect. It just has to be better than humans. And that's pretty easy when you use good data. So any questions? Oh.
Yeah. How about if you have like 90% of your project already estimated with some of the methods, and then the new story will arrive, like one story?
Yeah, so scope creep. What we can actually do is, I mean, depending on your project, your team, how it works at your company, we can also simulate scope creep. So in general, you might just say, oh, we might get like 10 tasks. Within a project, we might get 10 new tasks. Or we can look at a past project and say, oh, this one, we started with 20 tasks and it ended up 25, and work out a factor.
You don't have to actually rerun the estimations for the whole bunch, because you allow this buffer of some tasks that will come in
Yeah, it depends on like the assumptions that you have at the beginning, and you can work them into the estimates that you choose to make.
Yes, you don't have like a estimate for a single user story. So you have to estimate for a bunch of them always.
Yeah, so in the tool you put in like 10 stories, and it tells you the probabilities of each. And it's not about so much the individual, because we believe like in general the lead times kind of even out. Some big tasks, some small tasks, and so once you start estimating a few tasks, it averages out.
So I guess you also don't like put those stories to the next sprint. You try to contain and finish them all in the time periods that you estimate. 'Cause that would be like another problem. Like only a bunch of them are unfinished, and then you have to.
Yeah, we work in Kanban at Lunar Logic, and so it's all about the flow and the continuous work, and so we don't work in sprints, but you can actually set the tool up, not our tool, but you can set up estimates that work on sprints as well. We good? Any other questions? Thank you very much.